Good morning, everyone, or good afternoon, good night, wherever you are. Today, I'm going to be doing a Microsoft online assessment. So, yeah, this is a LeetCode premium feature. Shout out to LeetCode again for the platform. Please buy premium. It's worth your money because you can practice mock interviews across Google, Meta, Amazon, Microsoft. If you're targeting FANG. These mock assessments are super helpful. I've done a few, and yeah, pretty accurate as well. So yeah, let's just get straight into the Microsoft phone interview. Yeah, so this is a mock assessment. Each It's a phone interview simulated for Microsoft. Each session will include up to 3 questions. We'll have 1 hour and 30 minutes to complete all questions. There's going to be a timer, and yeah, that's pretty much it. Let's just start this thing. Cool. Binary tree question right off the gate. Let me center myself. Given a binary search tree, find the lowest common ancestor node of two given nodes in a binary search tree. The lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants. Okay. What do we have here? The LCA of two nodes 2 and 8. So what's the lowest common ancestor of 2 and 8? It's equal to 6, right? What's the lowest common ancestor of 2 and 4? It's 2, okay? P and Q will exist in the BST. So, okay, the lowest common ancestor is pretty much the first parent. Oh, this one's 3 questions. The lowest common ancestor is the first parent that's the first parent of both of them. Kind of. So for example, what's the lowest common ancestor of 3 and 7? It's 6, for example. If we're given this, right? So the first ancestor in the tree that both of them have. We have a binary search. We're given a binary search tree. So, what's a binary search tree? A binary search tree maintains these properties. Every node in the left subtree is less than the current node. Every node in the right subtree is greater than the current node. Apply that recursively. Okay, cool. And then everything is unique. Okay. So what I'm thinking is, would we just be able to search for a value? Because we know, example, we pretend we're looking for 5 and 7. What if we're looking for 0 and 5? Okay, maybe we can just return at the first value that's in between the range of the two nodes. So I'm thinking something greedy like that. Because pretend we're looking for 2 and 8. Pretend we're looking in 2 and 5, right? Yeah, I think that would work. Yeah, we can just return the first value. Pretend we're looking for 4 and 7. This is right in between it. What if we're looking for... Oh wait, there might be... What if we're looking for 7 and 9? We're looking for a value... Yeah, because for something to be an ancestor of both of them, since it's a binary tree, it needs to be in the middle of those values for it to be an ancestor. Is that true? Yeah. For anything to be an ancestor of these two nodes, it needs to be a value that's in between. So I think that'll work. Let's just work through an example here. Let's say we're looking for the ancestors between 0 and 5. So we're at 6. Since we're looking for 0 and 5, we're at 6. 0 and 6 is not in the range, so we go down to 2. Then 2. Then we return. Okay, let's see if... Is it that simple? Okay. I think that'll work. I'm trying to think if I can break that. Okay, whatever. We're running out of time. Let me just implement that. I think that'll work. 0, 5. Okay, let's try like 7 and 9. Yeah, that'll work too. What about like... Yeah, that'll work. That'll work, I think. So let's just say if we want to get P on the left. So what we want to do is the heck? So we want to get P. We want to get the lower value on the left so we can do the proper comparisons. So if P dot val is greater than Q dot val, then we're gonna swap these references. P, Q. So we'll say Q is equal to P. So we swap these references. But we'll just say current node equals root return current node. So we'll say while the current node dot val is less than P dot val, or current node dot val is greater than Q dot val. That means it's not in the range. Then we're gonna keep going. We'll basically say if current node dot val is less than the P dot val, the lowest one, then we need to look at the right side. So current node dot right, else current node dot left. I think that should answer. Oh, am I gonna time out? Uh-oh. What? Wait, P and Q will exist? Oh. What am I doing? You fix this test case. I think that'll work. Let's go. Next one. That's interesting. Okay, time and space complexity. Space, I'm actually using no space, which is good. I'm just using pointers. Let me do it. Time equals, I mean, time is O of n, because if it's, worst case, if the binary search tree is just a bunch of nodes on a bunch of left children, it'll become a big list. But if it's a balanced binary tree, it can get to log n. But space is actually a nice O of 1 because we just manage pointers here. So, cool. Let's go into the second question. You're given two strings. Let's see, zoom in, adjust this. You're given two strings, version 1 and version 2. Compare them. A version string consists of revisions separated by dots. The value of the revision is its integer conversion, ignoring leading zeros. To compare version strings, compare their versions in the left to right order. Okay. So we're given version 1 and version 2. So return true. Okay, return the following. If the version 1 is less than version 2, return -1. If the version 1 is greater than version 2, return 1. Otherwise, return 0. By dots. The value of the revision is this integer conversion. We have to ignore leading zeros in left to right order. Okay, we just have to ignore missing zeros. Okay, it's giving a few rules here. Now, let's just parse this out. Then work through the examples. Starting to make sense. Reading the examples, I feel like that's what made me... Reading examples and trying to come up with good examples is what I think helped me improve at these algos a lot better. What's this one? Given two negative integers, num1 and num2, represented as strings, return the product of num1 and num2. Okay, but we can't convert it. Okay. Wow, Microsoft is asking the good questions. Let's see. So we're given two version strings. Compare them. A version string consists of revisions separated by dots. Okay. Compare the revision in left to right. If one of the versions has fewer revisions, treat the missing revisions as 0. Okay, if one of the version treat it as 0. Okay, I think this is pretty easy. Then we just take version 1 array, and then we split that by the dot. Then we take version 2 array equals version 2. Let me quickly just text my friend, tell him that I'll meet him at the office real quick so he doesn't mess with me. Because that second question is going to be a while. I'll be like, I'll meet at the office. Okay, let's lock in. So what we're going to do is we're literally going to split these. Once we split them, we'll just start comparing them. And if one of them is missing, we return a 0. So what we're going to do is we'll return 0. That's if they're actually like equal. But we'll just say for I in range, the length of the max, or range of, we're going to take the max of each one because we want to go through the longest one. So we'll say max of the length of version 1 array and then the length of version 2 array, right? So what are we going to do for these elements? Max length. So we're going to go through these elements and we're going to say 1, so we're going to get these two elements and we're going to just convert them to integer. If we convert them to integer, it will ignore the leading zeros already. That's just how integer conversion works. So we'll say if lm1, we'll say we might get index out of bounds here. So if I is less than the length of version 1 array, then we do this. Right? If I is actually in bounds, else just return 0. Same thing with here. We have to follow this logic, but for the version 2 array. If I is less than the version 2, okay. If lm1 is less than, because we have to go from left to right. Yeah. If lm1 is less than lm2, return -1. Elif lm1 is greater than lm2, return 1. Otherwise, we just keep on going. Otherwise, we could, and if like none of these conditions ever break, that means they're equal and we just submit 0 there. Nice. Okay, last question. We need to like Excali draw this out. Let me open up Excali draw. You're given a num1 and num2. Wow, the reason I need to use Excali draw is because this is just like an elementary division or elementary multiplication right here. So we go multiply. Do I even remember how to do this? Okay, let's just do like 10 times 10. What's 10 times 10? 100. So how do you do this? 0 times 0. Or like, okay, how do you do this? 10 times 10. Let's just work through our elementary division. 12 times 10. This makes better. So what if we just do 2 times 0? That's 0. 1 times 0? 0. What is this? The 12, this is supposed to equal to 120. 1 times 2 is, I think we have to add it here. 1 times 2 is 20. 1 times 1 is this. there any carryover? Then we just add these. Here we go, 4, 5, 6 right here. Multiply. 6, okay. 3 times 6 is 18. Okay, now there's actually carry here. When do we use that? 18. Do we just like multiply by 3 here? Let's do an easy one. 23. 25 times 5. What is that? 125? Got me doing some math out here. 5 times 5. 5 times 5. Do we just write straight 25 here? Do we do this? Okay, so for the 5 times 5, we just write 25. 2 times 5 is 10. But I think, okay, so I think we need to keep track of, we need to shift it. We need to shift it by these indices. So if I'm multiplying by this index, 0, 1, I think I need to shift it by the addition of these two indexes, because if I had, what's 25 times 25? $625. So let's do 25 times 25, and then we'll see the logic for shifting these. 0, 1, 2, 6. Say we have 5 times 5, we put 25 here. I don't think there's carryover then. 2 times 5, that's 10, but we shifted over by that, by their indices. Okay. What's 2 times 5? 2 times 5, 100 again. Two times 2 is 4, but we have to shift it by 2. 4. Okay, so we just do elementary, and then we just add it up at the end. So I think we could just keep a running sum. But I think we just do elementary, but we figure out what index to place the multiplication. But what if it's a larger number? If it's a larger number, like it's 5 times 5. What's 5 times 5? 25. Okay, we know where to start it, and we just keep going to the left and adding it there. I think we write. Okay, we're probably gonna have to build this backwards in some array. Okay, this is it's a good question. Let's just I think what we'll do is we're gonna have like some result array. And if we do, let's just do 25 by 25. What's 5 times 5? Or we'll reverse these two, but we'll basically have a pointer here. Then we have like a second loop going through the top one. So what's 5 times 5? 25. So if we know mul is equal to 25, what we'll do is we'll figure out the indexes. Since these are at index 0 and 0, we put the first number here, and then we put the next number here. Or sorry, yeah, 5 times 5 is 25. We go like that. What's 5 times 2 times 5 is 10. So what we're gonna do is we're gonna add 0 here, and then we're gonna add 1 here, and then we move on here. Yeah. So I think if we just let's just write that code, not reverse. So we reverse that. We'll say result return. Then we'll say result dot reverse again. Dot join result. So what we're gonna do, we'll say for I in range just put the smaller number at the bottom. Just put the smaller number at the bottom. Just cause if the length of num1, just to make it look, just to visualize it better. I don't think that it'll actually affect the calculation, but dude, it's hot in SF today. It's like pretty much record for March. Well, I don't know about record, but sorry, I'm blocking myself. So we have num1. Okay, if num1 is actually greater than, we swap them. For I in range, what was I doing? For I in range length of num1. For j in range length of num2. What did we say? We're gonna multiply them to get the result. Or mul result equals I think we can multiply each digit. Say num1 at I multiplied by int num2 at I or at j. So that multiplies them. That gets the result of those two. And then where do we need to start where do we need to start adding it? We'll say while the multi-res is actually greater than 0, because we're going to be like right shifting off of it. What we're going to do is current digit equals, we'll get to get the last digit, we'll mod 10, and then eventually we'll do current digit equals current digit, the integer division to right shift. This is how we extract the last digit of a number. So we have so we'll pretty much do that, and we'll say current index equals I plus j, like I mentioned. So what we're gonna do is we're gonna try to insert this if I plus j is greater than or equal to the length, or if it's I plus j is actually equal to the length of the result, we're gonna do result dot append 0. Just so we're not doing any out of bounds. But then after, like I mentioned, we're gonna do we're gonna increment the index. But what we're gonna do is we're gonna say result at the current index is equal to multi-res. We have to divide multi-res here, or right shift multi-res, but we grab the current digit equals the current digit plus equals like that. Is that it? And then gonna fail. Okay, no attribute reverse string. Okay, num1 equals reversed. Reversed. Reverse string. Let's just convert it to a list. For I in range length of num1. Okay. Yeah, I mean, let's convert it to a list out here. Okay, we reverse the string, they convert it to a list. Because that's what it's complaining about. Okay, perfect. It's just with the join now. For in result. Convert each element to a string. List out of range, current index. Okay. What happened? Let's do simple 10 by 10. That was a bad result. 10 by 10. Current index. Current digit. How is, if the current index is greater than or equal to, how's that happening? Are we messing with the result? I should probably just dry run this, but okay. Are we messing with the result here? What's the current index? 0, 1, 2. For I. Okay. I think we still need to add what we can do is here as well. Yeah, because 0 times 0, then we don't actually add. But we still need to, let me see. Let's do this. While, we'll say while, something like that. Nice. 10 times 10 equals 100. What is this? Should be 250. Okay. Why did it like tweak on this big one? Let's see, print. One, two, three. Six times 3 times 6 is 18. Okay, let's do this. 3 times 6. Let's do this math. Last piece of debugging and then we're done. Delete, 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 delete. Let's go. Okay. 3 times 6, 18. 6 times 2. 6 times 2 is 6 times 2 is 12. I'm cooked. 6 times 6 is 6. What should this equal? So after the first one, so that's the first one. Okay, 5 times 3. What's 5 times 3? So this is the first one, right? What's 5 times 3? 15. 5 times 2, 10. 5 times 5, 5. That's good. Let me bring this down a bit. Because this should equal 8. This 8, 10, 0, or 8. Oh wait, okay, now it gets trippy. 8, we get 3 here, we get 7 here. Okay. I think we just need to sort of add these up. Like when we add 5, we need to carry it over. Wow, that's annoying. Let's see. We'll do 5, that's 13, or that's 3. Carry over here, 1. We'll carry over here, 1. What is this? 5. 7, 1, 5. 7, 1, 5. What is this? 13, 14. Look at this. Okay, now we do the last one. 4 times 3. 4 times 3 is... So I already know what I'm doing wrong. It's because some of the elements there are double digits. What's 4 times 3? 12. Look at this. 4 times 2, 6. Or sorry, 8. Sorry if I'm doing math. This thing's cooking 4 right here. Sorry, right? Okay. What's the answer? 5, 6, 0, 8. I'm already messing this up. Did I do the math properly? Because this should already be 8. Oh no, I'm not even like... I wasn't indexing them properly. I wasn't indexing them properly. So let's just do this like this. Okay, 8 times 6, 18. 2 times 5. 2 times 5 is 10. What am I doing here? Okay. 3 times 6, 18. 3 times 6, 18. 2 times 6, 12. And you can see I can't even do basic math skills after working through this question. 0, 1, index. What is this? So we got 8, 3, 7. I think I just need to like do some addition after that. Okay, what's 5 times 3? 15. 5 times 2 times 5 here is 10. 5 times 1 here is 5. What's the answer here? Okay. Okay, here 8. 8, 8, 6. What's 4 times 3? 4 times 3, say this is like index 0, 1, 2, 3, 4, 5, 6. Okay, what's 4 times 3? 12. But we start on index 2 to 12 here. What's 4 times 2? 8. So we go 8 here. 4 times 1, 4. Now I think we just need to sort of build it up and then add the 2. Yeah, we can't convert the inputs, but we can convert the digits. I think I know these questions they like to do that. 8, 8, 0, 1 carryover. Or sorry. 8, 0, 1 carryover. 2, 10, 16. So we do 6, 1 carryover. So I think we need to do some elementary addition too to do the carryovers to actually handle this. Like when we try to add a digit. So what we can do is when we multiply the result, we can figure out how much to right shift it by. Or left shifted by. Left shift. We can just do this. We can figure out how much to left shift it by. And then wait. We're close. We just need to handle this addition part. Pretend our result is 0. multiply the digits against each other, do the print result here. What if we just need to parse this final output? Eight, 8, 10. We just move 1 here to 0, 6. Okay, we just need to finally parse the output at the end, and then reverse it. 5, 6. Okay, we just need to parse the output at the end. We're actually close. We don't need to change our logic too much. So we say for index num in enumerate, my brother's favorite function in Python. What we're gonna do is like if the num is actually greater than or equal to 10, what we're gonna do is result at the index is equal to equal to the number mod 10. So if index plus 1 is actually greater than or equal to the length of the result, have to capture that case. Result dot append another 0. But what we're gonna do is, if we're actually greater than 10, we're gonna chop our value and then add to our next index plus equals to 1. That should work ish. Nice. Hopefully that works. That's a hard question for me. I don't know. Please, please, please. Okay. We're getting close. I'm just gonna hard code this case. If num1 I feel like there might be edge cases when there's leading zeros that I need to chop off, but we'll see about that. Okay, I'm getting close. Oh, this is rough. Okay, let me see. Let me see if it even calculates 99 properly. 99 times 99. Why can't it calculate 99,999 properly. What am I doing here? Okay, once we get this case, it should work. One. It's like literally, this thing is so funny. It's gonna look like this. What if it... Okay, what if it could get to 2? Can it ever get to 2? Oh, it got to 2. While current num is greater than or equal to... Okay, wait. Yeah, it's missing 1. Okay, while the current number is greater than 10, we'll just say if num is greater than equal to 20, we'll do morale's low. If num is greater than 20, we'll do index plus 1 of the result. Okay, what we'll do is like plus equals 2 here. We'll just handle a couple of cases. If num is greater than or equal to 10. 1. Else, we just don't do anything. At the end, we do go like this. Holy crap. Please work. Please work. Oh my god. Okay, it might be going over. It might be integer overflowing. It might be multiplying. It might be like in the third. It might be even higher than that. So we have to do. Well, you current number those num. Something like this. The number is like larger than 20. Like that. Please work, please work. Let's go. Let's go. This is going up. This is going up. Okay, let's see my result. I'm gonna finish the session and we'll see the report when it generates. This is going live. This is going live. Wow, 3 mediums? 3 mediums in, what is it, less than an hour? Okay, let's let this run. Okay, my report is generated. So they asked me 3 mediums. So I finished it in about 55 minutes. So about less than 20 minutes per. Time allotted 1 hour 30. I took really long on multiply strings, but overall I beat 67% of users. Decent score. I need to get back, start studying some math because that was, I forgot how to do elementary division or multiplication. But no, I'm happy to solve those problems. I've never solved those problems before, so like this multiply strings is a good question. Yeah, I never solved that question before. Let's see how many questions. Yeah, cool. All right, sounds good. Thanks everyone for watching that video and watching me grind through that. That was a Microsoft online assessment, and see y'all in the next video.